Hi everyone, welcome to Leetcode Biweekly Contest 120. Wish me luck. Sorry if there's any background noise at any time, by the way. I think there are some people over right now. Okay, let's go. Undirected tree. But if it's rooted. Let's place an amount of coins equal to the product. Okay. And cost. Okay, if I want to maximize, either I take the three biggest or I take like the top biggest and the two smallest. Yeah, and there's no negative costs as well, which is nice. For you in. So I'm just going to create an adjacency list. I feel like I'm going really slowly, but it's because I'm really scared that I'm going to make a mistake. For you. Okay. If the length of biggest left. Oh, let's put in this. Like this, if length of biggest less than 3, then there's one coin. Sure. 0, 1, 1. Oh, that's not correct. Let's do max is 0. That looks correct to me. Okay. How many non-empty subarrays can I remove such that the remaining array becomes positive? Okay, you can move the whole array, which is nice. So let's just buff it on either side. Actually, I'm going to use my ordered set because I think it's easier. Push back, I guess, 289. Okay, so now for int. Actually, this is not what I want. What I really want is ordered multi-set. I think it's something like that should work. Ten, 10, 7, that's not correct. Okay. Okay, I'm actually not sure why this doesn't work. Yeah, why doesn't this work? Oh, I see. It's because I'm being dumb. Yeah, okay, I was being dumb on this question. I'm not checking a lot of other stuff. Okay, this code is honestly horrible. What? What is going on? Okay, I don't know why my code is dying. Yeah, I'm just gonna... Oh, if R is greater than... 1073. Okay, that's better. Largest... Okay, this might be like a 2. Yeah, this could be a 2-pointer question. Zero. So let's just sort it. Okay. So I want twice. I want the sum to be less than 2 times. Actually, yeah, this code is not correct, I believe. I might be able to binary search on the answer, actually. Oh no, binary search on the answer doesn't work. Maybe I can. Maybe I can 2-pointer this. I do have to think though. Okay, maybe I'll think about it the other way. So I want PSA in my I want this sum to be less than... I need it to be greater than... Oh, I think I'm stupid. Okay, I'm dumb. Yes, I guess none. Sum is greater than... what's this int? Okay, I at least got ACs, but my time was honestly horrible. Okay, like, I guess I'll check Leetcode China. My time was 16:02, which is honestly horrible. Like, that was not a good contest for me, but... Oh, nobody on Leetcode China has finished yet, which means I might be alright. Okay, I'm gonna go through the solutions, and then once I go through the solutions, we'll see if any the leaderboard updates. Okay, question 1 and question 3 are the same, which I didn't actually realize because I didn't look at question 1 until the end. That's one of the reasons why I go in reverse order now, is because I can just submit question 3 solution to question 1. Anyway, in question 1, and because the constraints are so low, it's good enough just to brute force all subarrays, like try remove all subarrays, get the resulting thing, and check whether that's increasing or not. But because I'd already coded question 3 and gotten correct, I might as well just copy paste that solution to question 1. So I'll go through the solution to the hard version when I get there. Okay, this question, it threw me for a bit. But essentially, the idea is like, say we sort nums, and say the nums look something like this. It's useful to consider it sorted, because now if I fix the biggest side, then I guess all the smaller sides must be strictly to the left. And the first observation is that for a fixed nums r, for a fixed longest side, I might as well use every other side to the left, because there's no point of missing it. There's no point like not using any of these sides, because these ones just make the sum of these ones bigger, which can never make this condition false if it was already false, and it would also maximize. Why do I have music? Okay, I have no idea what that sound is, but I'm going to ignore it. And so I might as well use the entire prefix. So, and also like out of all of the longest sides that work, I should choose the one with the biggest longest sides. So I've got to get the sum of all numbers, and I process like, I guess, the longest side in decreasing order, and I try each of them as a candidate. The way I check it as a candidate is it's like a set of numbers can make a polygon if the sum is at least twice the biggest value. That's just a rearrangement of the formula. And so that's all I do. And then let's say if the 10 doesn't work, for example, then I will just subtract 10 off the sum of the remaining sides. Hopefully that makes sense. And I return -1 if I don't find anything. Okay, this question is like, I kind of did it in the dumbest way possible, I feel like. But the way I thought about it was, let's say we have some array like this. And then let's say we have some subarray like AL plus 1, all the way up to AR, and then all the way up to AN. So let's say we have a subarray, and like this for example would be the subarray move, the subarray from L to R. Now, how do we determine whether this is a incremovable subarray, whether subarray from L to R is incremovable? Well, there's basically 3 conditions. You need this prefix to be in increasing order. You need this suffix to be in increasing order, and you also need, like, I guess, the element to the left, like this A4 here, must be strictly less than this element, the first one to the right. And so, in my solution, like, instead of counting the number of subarrays directly, I instead try to enumerate these elements to the sides of the subarray, and I try to figure out how many pairs of these elements satisfy that the prefix up to the first element is increasing, the suffix from this second element onwards is increasing, and the first element is smaller than the second element. So let's start with the first condition. How do we tell whether the first element, I guess the prefix leading up to the first element, is increasing or not? In my code, I just generate the longest increasing prefix, and then check whether this element lies within that longest increasing prefix. So for example, if this was the longest increasing prefix, then the prefix from A1 up to A3 is definitely increasing as well. But if the longest increasing prefix was only length 2, then the prefix up to length 3 definitely isn't increasing. And I do the same for the suffix. I find the longest suffix which is increasing and the longest prefix which is increasing, and that's how I get those conditions. And for the last condition, I need to make sure that this element is smaller than this element. So the way I do that is I kind of loop through all possible these elements from left to right. And when I consider a candidate, I kind of have like a multi-set of these values, of the possible prefix values. And yeah, it's like, I don't actually need a multi-set because this is sorted. I could actually just do a binary search upon retrospect, but I didn't think of that in contest. Yeah, you don't need the multi-set, you can use a vector. But pretty much, pretty much in my solution, which is not the best, I iterate through all of these possible right elements, and I keep track of these left elements in a multi-set, and then I just count how many elements in the multi-set are less than AR plus 1. And specifically, I only add an element to the left multi-set. I only add an element to the multi-set if it satisfies the condition that the prefix up to it is increasing. So in my code here, if the prefix up to this element nums take2 is increasing, i.e. its index is less than or equal to the longest increasing prefix, then I add it to my multi-set. And then if my current suffix is increasing, then I count the number of elements in my multi-set less than my current element. This is honestly a horrible implementation, and I would definitely not do it like this again. Anyway, okay, this question is fairly standard. The observation is that for the maximum of 3 different numbers, either you multiply the 3 biggest numbers, or you multiply the biggest number and the 2 smallest numbers. The reason why you choose the 2 smallest numbers is in case those 2 are negative. For example, if your values were something like this, you'd either multiply the 2 by 4 by 5, or you'd multiply 5 by these 2 negative numbers. So it suffices just to keep track in each subarray. In each subarray, keep track of the 3 biggest elements and the 2 smallest elements, which I call big and small. And then I guess if it is less than 3 elements, there's only 1 coin. But otherwise, it's either the product of the 3 biggest elements or the biggest one and the 2 smallest elements. And a 0 here in case it's negative. And in my DFS, I guess when I recurse to the child, I get the biggest and smallest elements in that child subtree and kind of merge it into these lists. And because like they only have length at most 3 each, like this can actually be 2. Because these only have small lengths, then everything's done in linear time. So I think this is fairly straightforward. Sorry if those explanations didn't make sense, but check the leaderboards. Okay, I've won on Leetcode US somehow. I didn't expect to, because that was honestly horrible. 1602. Let's check Leetcode China. Leetcode China. Okay, so it says Leetcode China doesn't have any souls, but I don't know whether that's just the leaderboard hasn't been updated yet, which I strongly suspect is the case, because it has been 24 minutes and nobody has, like, it doesn't show any. Oh. Yeah, it doesn't show any souls on question 4, which can't be correct because it isn't that difficult. But anyway, I think that's a good enough rating. Like, let's say I do happen to win this contest. My rating is 3,674, and Neal Wu is at 3,686, only 12 points, which means I'm pretty sure I have enough rating, and after this contest, I'll be world number 1. In fact, I might even be very close to the highest ever rating on Leetcode, which I've achieved at 3,725. So all in all, like a decent contest, even though I felt that I performed really badly in it. Anyway, thank you so much for watching, and I'll see you guys soon.